So this problem is just a continuation of the previous problem that we had. So this time we're going to answer letter B. So last time in the previous problem that we had, we were able to answer the letter A, this question, which is a mass of zero point 0.1 kilogram is placed in each rack. So find the tension in each coupling. Now, this problem is still from the Cambridge Mechanics book. So the topic is connected particles. More specifically, this is on the objects connected by the rods. Now, question letter B. So the same given, we were just asked to find the tension in each coupling if instead the zero point 0.4 kilogram is all placed in the last track. Because remember, in letter A question, the zero point 0.1 kilogram was placed on each track. That's why each track had a mass, of 0.3 kilogram. Now this time, in this problem, the 0.4 kilogram will be placed only on the last track. Okay, it will be on the last track. Now, basically, of course, as always, we need to draw the diagram so that the forces acting on the engine and each track will be shown on the problem. So I will just be making use of the diagram here. So it will be really fast because it's to consume a lot of time. We're going to draw. I'm going to use the diagram given. Okay. Copy. Okay. So this is the diagram. Now, so the first first part of the diagram on the right, this is the one for the engine. So based on the problem, it's the same. So the driving force is 3 Newton. So the weight the weight will be 8 Newton because the mass is 0.8 kilogram based on the problem. So the resistance is 0.6 Newton. So we have here between the engine and the first rack, that is your T sub 1 or the tension 1. And the next, we have here your 2 Newton weight because based on the problem, each track will be consist of 0.2 kilogram mass when empty. So the resistance is 0.1 Newton. And then we're going to have here your tension 2 between the first track and the second track. So we have your tension 2 in here. So the same, we're going to have the same weight, mass, and resistance with the first track. Next, we have your tension 3. Oh, sorry, this is tension 3. Tension 3 is here. Tension 3. So the same also, the same weight, mass, and resistance. That's based on the problem. And then here's the last train. And the last train, this is the one that is different among the others. Because based on the problem now, the 0.4 kilograms will be placed on the last train. So that's why here, the 3 tracks have the same weight, which is 2 Newton, because their masses are the same. That is only 0.2 kilograms. So the last track will have a weight of 6 Newton because the mass here will be 0.2 plus 0.4. So the mass in here is 0.6 kilograms. So just a reminder, in mechanics, the acceleration due to gravity that we are using is 10 meter per second squared. That's why we're able to come up with the following weight in the given diagram. So as always, we need to get first the acceleration using the Newton's second law for the system. So we already computed it in the previous problem, the previous video that we had. So here, what we're going to do is we're going to have the same result. So a while ago, the result is 1.45. So of course, it will be the same because the problem is the same. We did not really change a lot in the problem. Okay, so that is F is equal to MA. So this will come up with 3, which is the driving force, minus, that will be equal to 0.1 as the resistance. Okay, the total resistance will be 0.1. So that will be 0.06 and then 4 times 0.01. So it's equal to 2 times A. If you want to recheck, you can just pause the video and try to compute, try to recheck. And that is the result. We had it in the previous video. So here we're going to arrive with the acceleration, which is 1.45 meter per second squared. So it's the same. So this is the same acceleration as what we had. Now this time, let's try to recall that the acceleration is the same for the engine and for each truck. So to be able to find the tension in each coupling, we're going to do the same thing as well with what we had in the first video. So we're going to compute each tension by using the Newton's second law. Okay, so let's start. So let's start with the first one. So for the first one, for the engine, this one. So again, we will be using F is equal to MA, Newton's second law. So this will be for the engine. We're going to have 3 minus the resistance is 0.06 minus we have your tension 1, T sub 1 for the first tension. So that will be equal to 0.8 A. And that will be equal to 0.8 A. So of course, to solve for your T sub 1, this will yield to, so that will be T sub 1 is equal to 3 minus 0.06 minus 0.8 times the 1.45. So approximately, we're going to arrive here with the T sub 1 will be equal to approximately 1.78 Newton. We're going to express into decimal place. Please pause the video if you want to check it. For the tension number 2, tension 2, this one, we're going to solve it on the first track, So that would be T sub 1 minus 0.01 minus T sub 2 is equal to, so the mass is only 0.2, so times the acceleration. So this time we already have the T sub 1, the value is given, and the A is also given. So to be able to solve this, what we're going to do is we will just substitute the values of the acceleration and also the T sub 1 or the tension 1. So to solve for your tension 2, that will be equal to T2. That will be T2 is equal to T sub 1 is 1.78 minus 0.01 minus 0.2 times the acceleration, which is 1.45. So therefore, we will come up here with, so our T sub 2, wait, let me write it over. So our T sub 2 will be equal to 1.48 Newton. I hope we will have enough space here. Okay, now let's proceed to T sub 3. So for your T sub 3, be able to compute for the T sub 3. So that will be T sub 2, T sub 2 minus 0.01 minus the T sub 3 is equal to, still the same, we're going to have 0.2a. 0.2a. So therefore, we're going to solve for your T sub 3. This will be equal to T sub 3 is equal to T sub 2 is 1.48 Newton minus 0.01 minus 0.2 times 1.45. 0.2 times 1.45. So this will give us the value of this sub 3 will be equal to 1.18 Newton. Sub 3 will be 1.18 Newton. Okay, next, the last. So for the last, we're going to have here T sub 3, that's on the upper part. Going to have T sub 3 minus 0.01 minus the T sub 4 is equal to 0.2a. So this is the last that will have 0.2a because the next, the mass will be 0.6a. So we're going to come up here with the value of your T sub 4. So this will be equal to T sub 4. T sub 4 will be equal to, so that T sub 3 is 1.18 minus 0.01 minus 0.2 times the A. So the A is 1.45. So the T sub 4 here will be, you can pause the video if you want to check, 0.88 Newton. This is the T sub 4. And if we're going to include, we're going to have the last part, it will be T sub 4 minus 0.01 is equal to 0.6a. So this will be the last, this one. You can also compute for the T sub 4 there.